gotten started with the thermal comfort database 2, let's continue on and look at other ways that we can take this data set and extract insight from it. We've gone through a lot of the different aggregation functions, which was a review, but now we'll look at a set of functions that are related to pivoting. And pivot tables are something that if you're really advanced spreadsheet user, you probably have used them before. They're basically a way that you can take longer, skinnier data sets or a certain subset of columns and pivot those columns into rows based on some sort of aggregation. Let's look at something related to this data set, which is more than just looking through the code or looking through the data. Let's look at one of the columns called thermal sensation. I mentioned that every row in this data set is a person who gave feedback about how they felt in an environment based on the environment, the person, their age, all the different attributes they have about them. Thermal sensation is a scale that 0 is in the middle. 0 means that your thermal sensation is neutral. You're not feeling anything really one way or the other in terms of hot or cold. +3 is very hot. -3 is very cold. Of course, +2, -2 are somewhat cold, and +1, -1 are somewhat hot and cold. You have these extremes from it's basically a 7-point scale from +3 to -3. And if we look at this, I already just did this aggregation value counts wise. You can see that 0 is the most common. People feel thermally neutral most often, slightly warmer, slightly cooler, slightly more warmer, more cooler, etc. And then you can also see down here that there are some studies which actually ask people to give feedback on beyond the 7-point scale. So they allow them to give fractions of those points. What we want to do is we want to get a sense of what causes people to feel thermal sensation either too hot or too cold. And the first thing we'll do to do that is we want to get rid of some of those points that are between the numbers. We're going to round them to the nearest whole value. What that does is it gives us only whole numbers when we look at these data. We want to do that because we want to use pivot table to understand what we're going to use that particular new column, thermal sensation rounded, in a pivot table. Let's just do this pivot table first. We've created this new data frame. We've executed using .pivot table, the index being the country, the columns being the thermal sensation, the values being air temperature, and the aggregation function, the mean. So what this does is it takes a lot of the data and aggregates it in a way. It's similar to the group by functions that we learned a while back, but it is similar to the format that you would do in a pivot table on a spreadsheet program like Excel. So here what we have is we have the thermal sensation rounded from -3 to +3 with 0 in between is neutral. You have each of the countries that you have the data collected from, and you have the average temperature that the person was exposed to at each of these levels. And you can see that there are some NANs in here because some of the studies maybe didn't have any participants that felt very cold or very warm. You can see there are differences from country to country. For example, let's say in Indonesia, the average of somebody saying that they feel quite cold is 23 degrees, where in China, somebody saying they're quite cold is 17 degrees. So you can see there's lots of differences here. And this is really a way of taking this large 100,000 row data set and creating a table of values that is more aggregated and more human readable from a high level. You can see how useful that is. This is even without visualization, which we'll get to here in a second. Let's say that you want to unpivot. You have a pivoted table, you want to unpivot. This is not so common for creating aggregations for human readability, but sometimes for creating data frames that are more useful for other functions like visualization, which we'll see here in a second. So you can pivot by using a function called .melt. And .melt will bring it back into this data frame, which is tall and skinny instead of square shaped like what we just saw. We learned the fundamentals of grouping and group by in the introduction to pandas. Now let's look at group by in the context of this data set. Here you have .group by in the country. You're taking the mean across that country. In this case, we're not just looking at the air temperature as a function of the thermal sensation. We're looking at basically grouping all of the columns according to country and taking the average or mean of each of the columns. Once again, this is only doing this for numerical columns that have numerical values and not text-based values. You could do the same thing by country using .median. So instead of mean, you want to look at the median. This is quite common in situations where you have skewed data that you don't want the outliers at either end of the spectrum to offset or to influence your aggregation metric. You might look at size. So this is like we've reverse engineered the function value counts, but it's not in the order of highest to lowest, it's in the order of the alphabetical order of the country. This gives you a sense of how you can use those functions with this data set. Let's move on now to plotting. So visualization and plotting, this is really a big part of what you learned in the Seaborn lessons from the first part of this whole section of videos. Let's look at the application of Seaborn to this data set. So as was mentioned before, this data set is very much a range of behavior type data sets. So you have these 100,000 rows of data. You want to get a sense of what are the differences between these populations. And we used aggregation functions to look at those values like mean and max and min, but we can use visualizations like box plots, which are really useful. Here we see the .info of our data frame. We see all the different information that we have from each of these rows. Let's take a look at, for example, air temperature and relative humidity of the data set. So just these two columns. Let's look at a box plot of these two columns. We're not using Seaborn quite yet. We're just using regular pandas plotting functions. Here you can see in the entire data set that the air temperature has a certain range. If you've never used a box plot before, the green line right in the middle is the mean. The box is the 25th to 75th percentiles. The two lines are the 5th to the 95th percentiles, and then the circles are the outliers in the fringes of the data set. Here you can see air temperature is pretty clustered and concentrated between 20 and 30 degrees roughly. Relative humidity somewhere between 40 and 60%. And you have some outliers in some locations even up to 60 degrees, it looks like, which those seem like really weird outliers. There might be some error in that data. Here we're going to, with pandas, we can also change attributes. We can change the colors. We can change the symbols, the figure sizes. This is a review of what we saw previously. Here you can see we made it horizontal. So we've used a box plot. We've set the attribute vertical to false. This is more readable. I like horizontal box plots often better because you're able to visualize the label much better. And if you have a wide range and you want to put it across an entire page, this is nice to do. Here you can see a box plot which is created using group by. So it's grouping by country. You're able to see air temperature and relative humidity in this visualization, country being the group by attribute. So we're taking a subset of the data set to create this kind of what we call panels. Allows us to see a lot of data at once from these two temperature humidity metrics of the database. And this kind of just shows, the differences between the different countries in terms of the data in the data set. Histograms, yes, histograms are very useful. You can create a histogram of an individual column, or you can create a histogram of all of the columns by just using .hist. We made the figure size quite a bit bigger. Histograms are great because you can also see the distribution of data, but you can see where you have these spikes in the distribution. So if you've never visualized a histogram before, basically what you're seeing on the x-axis is the range of values that you have for the numerical columns in the data frame. And the y-axis is the frequency that each of the values that you see is happening in this data set. For example, for age, there's quite a few people that seem to be in their 20s and 30s, not very many people above 50. There's only probably a few people that are close to 100. You get a sense from this age. And you can see the distributions across all of these data points. You can see a lot of them are normally distributed. Some of them are not. Some of them have different types of distributions. Here's a bimodal distribution for acceptability. So yes or no type of question. And so really a high level overview of the data in the data set. You can use density plots. This is something that we learned about as well with other types of data. Here, if we look at air temperature and a kernel density plot of that, you can see that quite a bit of the data is spiked around here between 20 and 25 degrees Celsius, which makes sense because a lot of these are indoor comfort studies. They're trying to keep people comfortable, so that's usually not going to have much data outside of that range. Scatter plots, of course, we learned a bit about in other episodes related to comparing two numbers. Let's say we want to use a scatter plot to compare air temperature versus relative humidity. We can do that. Just plot it real quick using scatter plot. We've done that before. We can also do that by adding another value for C or color, which allows us to give another dimension, a color-based dimension to our plot. Here you can see it's hidden, but on the x-axis is temperature, the y-axis is relative humidity, and the darker the point, the higher in the thermal sensation scale people have given that value. Darker on the right-hand side because people feel warmer, and lighter on the left-hand side because people feel cooler. People feel much colder as it gets to the upper left and upper right. It's getting hotter and people are feeling hotter. So you can see some patterns here. This is not a great visualization because there's quite a bit of data. You'd maybe want to filter some of this out to get some better conclusions in this sense. With scatter plot matrix, we can also do a range of scatter plots across all the different attributes. Here we create a subset of the data frame using air temperature, relative humidity, and thermal sensation. And we're creating a scatter plot matrix which compares these three properties of the data compare them against each other using scatter plots with a histogram on the diagonal of the plot, which is nice. The last few plots are not used quite so often. There's one called parallel coordinate plots. For example, we want to take 4 of these data points and plot them using parallel coordinates. Here you can see that it's basically like a comparison of 3 attributes and the levels of the colors of the lines according to the thermal sensation values. With this particular data set, this is not a great way to visualize it, but I wanted to show you how to do that nonetheless. In this video, we looked through ways to aggregate and visualize data from using the Thermal Comfort Database 2. We didn't get into the Seaborn data quite yet, but we will in the next set of videos.